So for example number 1, we are going to consider to evaluate the integral of quantity ax minus 1 times the differential of x over, okay, the denominator is 2x squared minus 3x minus 2. Okay, of course, we can factor the denominator. Although the denominator is quadratic, we have 2x squared minus 3x minus 2. It can be factored as two linear factors. And please take note that the integrand 8x rather minus 1 over 2x squared minus 3x minus 2 is a proper rational function. So we can decompose it into sum of partial fraction. Okay, so um, let us have the decomposition here. Okay, we will consider 8x minus 1 over uh, the denominator 2x squared minus 3x minus 2. And since the denominator can be factored into two linear factors, no, we have 8x minus 1 over the denominator can be factored as 2x, okay, the other factor will have x here. Since negative 3 ang middle term, then this must be negative 2 and this must be positive 1. Okay, so to check, 2x times x will give us 2x squared. Negative 4x plus x will give us negative 3x, and 1 times negative 2 is negative 2. So 8x minus 1 over 2x squared minus 3x minus 2 is equivalently 8x minus 1 over 2x plus 1 x minus 2. Okay, and you can see here that we have two distinct linear factor in the denominator, and according to the rule, for every distinct linear factor in the denominator, there corresponds a partial fraction rather in the form a over the quadratic factor. So hence, if we have 8x minus 1 over, okay, quantity 2x plus 1, x minus 2, okay, now for the linear factor 2x plus 1, there corresponds a over 2x plus 1. There corresponds a partial fraction in the form a over 2x plus 1. And for the linear factor x minus 2, there corresponds a partial fraction in the form b over x minus 2. Okay. So instead of using A1, A2, okay, we will just use A and B for the constant. And A and B here are constants to be determined. So hence, 8x minus 1 over 2x plus 1, x minus 2 can be decomposed into sum of partial fractions A over 2x plus 1 plus B over x minus 2. And to determine the values of A and B, we can actually simplify the resulting equation, no, by multiplying both sides of the equation by the LCD, 2x minus 1, x minus 2. Okay, sorry, this should be 2x plus 1. 2x plus 1, x minus 2. And multiplying the left member by the LCD, 2x plus 1, x minus 2 will give us x minus 1. Okay, and this is equal to a over 2x plus 1 times the LCD will give us a times x minus 2. And the second term times the LCD will give us b times 2x plus 1. So our problem here is how to determine the values of the constants a and b. And we can do that by substituting the values of x that will make the denominator 0. Okay, actually this is a technique, no? Okay, we will use the values of x that will make the denominator 0 to determine the constants a and b. And there are actually two values of x that makes the denominator 0. These are x is equal to 2 and x equals negative 1 half. No? Okay, so if we will use the value x is equal to 2, that is by equating the factor x minus 2 to 0. Okay, if we will substitute x is equal to 2 in the simplified form, okay, 8x minus 1 is equal to a times the quantity x minus 2 plus b times the quantity 2x plus 1. When x is 2, of course, x minus 2 will be 0, right? Okay, so what will happen? We will have 8 times 2 minus 1 is equal to, okay, the right side, in the right side of the equation, the first term will be 0 since 2 minus 2 is 0. Okay, so times is equal to b rather, okay, times the quantity 2 times 2 is 4 plus 1. Okay, so this will give us um, 16 minus 1 is 15, right? Is equal to 5b. And if we will solve for b, then b is equal to 15 over 5, which will give us 3. Okay, so we were able to get the first constant, which is equal to 3. Now, there is another value of x that makes the denominator 0. Okay, and that is x equals negative 1 half. So when x is equal to negative 1 half, okay, by the way, x is equal to negative 1 half is determined by equating 2x plus 1 to 0. When 2x plus 1 is equal to 0, then 2x equals negative 1, so that x equals negative 1 half. And when x is equal to negative 1 half, then the equation becomes 8 times 1 half. Okay, we are going to substitute x equals negative 1 half. Okay, sorry, this must be negative 1 half in this equation. So, okay, let me repeat this. So 8 times negative 1 half, okay, minus 1 is equal to, okay, this time the second term will be 0. So since 2 times negative 1 half will give us negative 1 plus 1, okay. So in the first term, we will have a times the quantity negative 1 half. Okay, we replace x by negative 1 half minus 2. Okay, now in the left member, 8 times negative 1 half will give us negative 4 minus 1 is equal to a times, okay, we have negative 1 half minus 4. Negative 1 half minus 4 will give us negative 5 over 2, right? So negative 5 over 2. If we will simplify or combine negative 1 half and minus 2. Okay, so the common denominator is 2, so that gives us negative 1, negative 4, which is equal to negative 5. So the left member is negative 5, okay, and this is equal to negative 5 over 2 times a. And if we will solve for a, then we can just multiply both sides of the equation by negative 2 over 5, okay? Or we can just have this as a is equal to, okay, 2 times 5 will give us 10, no? 10 over 5, so that a is equal to 2. Okay, so we have a is equal to 2 and b is equal to 3. Okay, hence, now we can now say that uh, 8x minus 1 over 2x plus 1, x minus 2 can be decomposed into sum of partial fractions a over 2x plus 1, but since a is equal to 2, then we have 2 over 2x plus 1, okay? Then b is 3, okay? So plus 3 over x minus 2, okay? Did you get it? So this is how we decompose the given integrand 8x minus 1 over 2x squared minus 3x minus 2 into sum of partial fraction. And if we will go back to our problem, no, if we will evaluate the integral of 8x minus 1 over 2x squared minus 3x minus 2, then we can write this as the integral of, okay, after decomposing the rational function, now it gives us 2 over 2x plus 1, okay, plus 3 over x minus 2 times the differential of x. And we can write this as sum of integrals, okay? We can write 2 before the integral sign, right? Okay, so we will have, okay, wait. Let us just not write 2 before the integral sign since the numerator, oh, okay, wait. Let me just write this as the integral of 2 times the differential of x over 2x plus 1, okay, then plus the integral of 3 times the differential of x over x minus 2. Okay, now look at the two integrals. If we are going to evaluate the integrals, no, both leads to logarithm. Okay, now in the first integral, you can see that the numerator is the exact differential of the denominator. Okay, if u is 2x plus 1, the differential of u is 2 dx. Hence, we can use the formula that the integral of the differential of u over u, when the numerator is the exact differential of the denominator, it leads to the natural logarithm of the denominator, right? Okay, therefore, we will have integral of 2 dx over 2x plus 1 is natural logarithm of the denominator 2x plus 1, okay? Then plus, okay, now please take note that the second integral also leads to natural logarithm. The differential of the denominator x minus 2 is equal to the differential of x. Therefore, 3 times the integral of dx over x minus 2 leads to the natural logarithm of ln of x minus 2, then plus the constant of integration. Now, we can also simplify this by using laws of logarithm. Okay, now look here. Okay, in the second natural logarithm, second term, we can use the third law of logarithm. Okay, we have natural logarithm of 2x plus 1, okay, plus natural logarithm of, we can express this as the absolute value of x minus 2 raised to the third power, okay, plus the constant of integration. Okay, got it? Okay, therefore, we will have natural logarithm of, okay, if we will simplify this, then this will give us a natural logarithm of, okay, quantity 2x plus 1 quantity x minus 2 raised to the third power plus the constant of integration. Okay, so we were able to evaluate the integral of quantity 8x minus 1 times the differential of x over 2x squared minus 3x minus 2. Okay, so this is the first example. And let us have another illustration on this. I hope that you can follow the discussion. And this time, let us consider the integral of quantity 3x squared minus 5x minus 4 times the differential of x over x cubed minus 5x squared plus 7x minus 3. Okay, so you can see that the integrand is in rational form and it is a proper rational function. The degree of the numerator is less than the degree of the denominator. Okay, so what we can do now is to determine if we can express the denominator as factors. Okay, specifically linear factors. Okay, we can actually do, maybe we can do synthetic division. If we have x cube, okay, wait, let me use other color. If we will have the denominator x cube minus 5x squared plus 7x minus 3, okay, and if we will do synthetic division, okay, there is no missing terms, therefore we write the numerical coefficient of the terms, okay, 1 minus 5, decreasing order din siya, no missing term, so we write 1 negative 5 7 minus 3. Okay, we can try 1. Okay, r is equal to 1. And if we will try I is equal to 1, r is equal to 1 rather, then we bring down 1. 1 times 1 is 1. Okay, we will have negative 4. Negative 4 times 1 is negative 4. Then 7 plus negative 4 is positive 3. And positive 3 times 1 is 3. Okay, so this will give us 0. So that would mean that if we have r is equal to 1, then one of the factors of the denominator is x minus 1. And the other factor is a quadratic factor whose numerical coefficients are 1, negative 4, 3. Okay, 1 minus 4, 3. Therefore, the other factor is x squared minus 4x plus 3. Okay, but x squared minus 4x plus 3 is still factorable. Okay, so we have x minus 1. We can factor this as x minus 1, x minus 3, right? Okay, so to check, negative x, negative 3x is negative 4x. Therefore, the factors of the denominator are x minus 3, then we have x minus 1, and x minus 1 is repeated twice. Okay, so of course, before we evaluate the integral, we have to decompose the integrand into sum of partial fractions since we have a rational integrand. Okay, and let us do it here. We have 3x squared minus 5x minus 4 over the denominator x cubed minus 5x squared plus 7x minus 3. And we can express the denominator in factored form. We have 3x squared minus 5x minus 4 over the denominator x minus 3, okay, x minus 1 raised to the second power. Okay, so if we will decompose the rational function into sum of partial fractions, okay, we have 3x squared minus 5x minus 4 over the denominator x minus 3 x minus 1 raised to the second power. Okay, I hope that you can still remember what you had in senior high, how to decompose fraction into some partial fractions. Okay, now please take note that in the denominator, we have one distinct linear factor, x minus 3, and one repeated linear factor, x minus 1, repeated twice. Therefore, for the distinct linear factor, x minus 3 in the denominator, there corresponds partial fraction in the form a over the linear factor, x minus 3. Okay, then plus for the repeated linear factor x minus 1 raised to the second power, there corresponds partial fraction in the form b over x minus 1. Okay, since repeated twice siya, so plus c over x minus 1 raised to the second power. If it is repeated 3 times, then we will have another term, b over x minus 1 raised to the third power. But since it is repeated twice lang, then for the repeated linear factor x minus 1 repeated twice, now we will have b over x minus 1 plus c over x minus 1 squared. Okay, and let us try to simplify the resulting equation. We have to multiply both sides of the equation by x minus 3, x minus 1 raised to the second power. And what will be the result? Okay, the left member is 3x squared minus 5x minus 4 equals, okay, multiply the right member term by the LCD, so that we will have a times x minus 1 raised to the second power plus b times x minus 3 times x minus 1 plus c times x minus 3. Okay, so we have the form in factored form. Okay, now we can have another form of the resulting equations, no, by getting the expansion of x minus 1 squared and multiplying x minus 3 and x minus 1. Okay, why is there a need to do that? No, kasi the values of x that makes the denominator 0 are not sufficient for us to solve for the values of the constants a, b, and c. So we are going to use another method to determine the values of a, b, and c. But of course, we will have first the values of x that makes the denominator 0. And these are x is equal to 1 and x is equal to 3. Okay, so when x is equal to 1. Okay, let us start with x is equal to 1. So what will happen? We will have 3. Oh, wait. Let's do the expansion muna para dire-diretso na mamaya. Okay, excuse me. Okay, so on the left member, we have 3x squared minus 5x minus 4 is equal to a times the quantity. Okay, the square of x minus 1 is x squared minus 2x plus 1 plus b times the quantity. Okay, let us have the product of x minus 3x minus 1, x squared minus 4x plus 1 plus c times x minus 3. Okay, so we can now consider the values of x that makes the denominator 0. Okay, so the first value of x that makes the denominator 0 is 1. So just equate x minus 1 to 0. So when x is equal to 1, okay, substitute in the first form, the factored form, so that we will have, okay, 3 times 1 square minus 5 times 1, okay, minus 4 is equal to. Now, please take note that when x is equal to 1, the terms that contains the factor x minus 1 on the right member of the equation will be 0, since 1 minus 1 is 0. So we will have a times 0 plus b times 0 plus, okay, so what is left? C times the quantity. When x is 1, we will have 1 minus 3, okay? Then we have here 3 minus 5 minus 4. Okay, and that gives us 3 minus 9, and 3 minus 9 is minus 6, right? Minus 6 is equal to 1 minus 3 is equal to minus 2. So we will have minus 2c. And if we will solve for c, then c is equal to positive 3. Okay. So we were able to get the value of c, which is equal to 3. Okay, now there is another value of x that makes the denominator 0, and that is x is equal to positive 3. Okay, determined by equating x minus 3 to 0. And when x is equal to positive 3, let us again substitute in the equation, the simplified equation in the factored form, so that we will have 3 times 3 raised to the second power minus 5 times 3 minus 4, okay, is equal to, now on the right member, this time, the terms containing the factor x minus 3 will be 0. Therefore, the second term and the last term, that containing the constants b and c, will be 0. So that we will have a times the quantity. Now x is equal to 3, so 3 minus 1 raised to the second power. Now, if we will simplify the left member, okay, 3 square is 9. 9 times 9 times 3 is 27, okay? So we will have 27. Now, negative 5 times 3 is negative 15 minus 4 is negative 19, right? And 27 minus 19 is 8. Okay, positive 8. So the left member is 8. Now, what about the right member? The right member is 3 minus 1 is 2, and 2 raised to the second power is 4. So that will give us 4 times 8. And if we will solve for a, then a is equal to 2. Okay, so we were able to get the values of A and C, and A is equal to 2 and C is equal to 1. But please take note that there are no more values of x that makes the denominator 0. There are only two values of x that makes the denominator 0, and these are 1 and 3. Okay, ang problema natin, we do not have yet the value of b, the constant b. So in that case, we can use the second method for solving the constants, okay, a, b, and c in the sum of partial fraction. And that is equating coefficients of x raised to n. Okay, so to have space, let me erase this one first. Anyway, we are done with the factoring. So as mentioned, no, another method is by equating, okay, we will equate coefficients. By coefficients, we mean the numerical coefficients, no, of x raised to n. And this time, it will be more convenient if we will use the expanded form. Okay, this one. We have 3x squared minus 5x minus 4 is equal to a times x squared minus 2x plus 1 plus b times x squared minus 4x plus 1 plus c times x minus 3. Okay, and we normally start with the highest power of x. And if we will look at the equation, of course, the highest power of x is x squared. So in equating coefficients of x to the n, okay, we can start with the coefficients of x squared, okay? If we will equate the coefficients of x squared, okay, now look at the left member, 3x squared, okay, we have a second degree term here, 3x squared, and of course, the coefficient of 3x squared is 3, okay? And there are no more second degree terms on the left member. So 3 is equal to. Now focus on the right member. In the first term, we have a times the quantity x squared minus 2x plus 1. Of course, if we will distribute a, okay, then we will have a times x squared. We have a second degree term, a x squared, and the numerical coefficient is a. Okay, we have another one here. Okay, multiplying b by x squared will give us bx squared, so that the numerical coefficient is b. So we have a plus b as the numerical coefficient of x squared on the right member. Okay, so we have 3 is equal to a plus b. We were able to generate an equation in terms of a and b. But we have already computed for the value of a. A is equal to, a is equal to 2, right here. Therefore, we can now substitute, okay, wait. We can now substitute the value of a in the resulting equation. 3 is equal to a plus b, so that we will have 3 is equal to a is equal to 2, so 2 plus b. And if we will solve for b, then b is equal to 3 minus 2, or b is equal to 1. Okay, so we are done. We have a is equal to 2, b is equal to 1, and c is equal to 3. Therefore, we can now express the rational function a sum of partial fraction a over x minus 3 plus b over x minus 1 plus c over x minus 1 raised to the second power. And since a is equal to 2, then we have 2 over x minus 3, okay? B is equal to 1, so 1 over x minus 1 plus c is equal to 3 over x minus 1 raised to the second power. Okay, but we are not yet done. We have just expressed the given rational integrand into sum of partial fractions 2 over x minus 3 plus 1 over x minus 1 plus 3 over x minus 1 raised to the second power. So going back to our problem, then we can express this as the integral of quantity 2 over x minus 3 plus 1 over x minus 1 plus 3 over um, x minus 1 raised to the second power times the differential of x. And we can express this as sum of integrals. Okay, let me go further left here. And if we will express this as sum of integrals, then we will have 2 times the integral of the differential of x over the denominator x minus 3, okay, plus the integral of the differential of x over x minus 1, okay, then plus 3 times the integral of the differential of x over x minus 1 raised to the second power. Now, the first two integrals lead to logarithm since the numerator is exactly the differential of the denominator. Now, the third integral can be evaluated by power formula, and since it can be evaluated by power formula, then we can bring up x minus 1 raised to the second power so that we will have, okay, 2 times the integral of dx over x minus 3 plus the integral of the differential of x over x minus 1 plus 3, okay, times the integral of, okay, bringing up x minus 1 raised to the second power will give us x minus 1 raised to negative 2, okay, times the differential of x. Okay, so evaluating the integrals, okay, integral of dx over x minus 3 leads to natural logarithm of the denominator x minus 3. Okay, it can be evaluated by the integral of du over u leads to natural logarithm of u. Okay, then the second integral of dx over x minus 1 leads to logarithm also. The numerator is the exact differential of the denominator. So natural logarithm of the denominator x minus 1. And by power formula of integration, the integral of x raised to minus 2 dx, by letting u is equal to x minus 1, this is exactly the form integral of u raised to m du. Therefore, the integral is x minus 1 raised to negative 2 plus 1 is negative 1 over negative 1 plus the constant of integration. Okay? And if we will simplify the integral, the first one, 2 times the natural logarithm of x minus 3 can also be written as natural logarithm of x minus 3 raised to the second power, okay, by using the third law of logarithm, plus the natural logarithm of x minus 1, okay, and simplifying 3 times the quantity x minus 1 raised to negative 1 over negative 1 will give us minus 3 over x minus 1 plus the constant of integration. Now, if we are going to use the first law of logarithm, we can express the first two terms as single logarithm. And we can have natural logarithm of the absolute value of quantity x minus 1 times the quantity x minus 3 raised to the second power. Okay, we use the first law of logarithm, then minus 3 over x minus 1 plus the constant of integration. Okay, so this is the integral. Medyo tataas ko lang yung minus 1. Okay, here. Okay, para hindi nakakagulo. Therefore, the integral is equal to the natural logarithm of the absolute value of the product of x minus 1, x minus 3 raised to the second power minus 3 over x minus 1 plus the constant of integration. Okay, so the two examples illustrate uh, integration of rational function by partial fraction, okay, where the first one involves a distinct linear factor in the denominator, and the second example involves one distinct linear factor, x minus 3, and a repeated linear factor, x minus 1, okay? And this is repeated twice, okay? X minus 1 raised to the second power. Now,